To solve an inequality, we know we want everything on one side so that we have a 0, which is done for us. And then we want to be able to factor this to find the zeros. And this polynomial is not beautiful, not really easy to factor. So we're going to need to find the zeros here using some techniques that we've learned. I'm going to use the rational zeros theorem, which says I'm going to take the factors of the 20 and divide by the factors of 2. So the factors of 20 are 1, 2, 4, 5, 10, and 20. And divide by the factors of 2, which are 1 and 2. So our possible combinations, of course we get positive or negative, all of these. We get positive or negative, 1, 2, 4, 5, 10, 20, and then each of those divided by 2. 1/2, 2 over 2, which is 1, 4 over 2, which is 2, 5 over 2, 10 over 2, which is 5, and 20 over 2, which is 10. So this is our list of possible things. Now I don't want to waste tons of time practicing or testing different things here. I'm just going to jump right to what I think is going to work, and that's 4. And we can do our synthetic division to test whether or not these work. So bring the 2 down, times 4 is 8, negative 19 plus 8 is negative 11, times 4 is negative 44, add those we get 5, 5 times 4 is 20, and add those we get 0. So now we have a factored form of x minus 4 times 2x squared minus 11x plus 5. And then we want to factor this here. And that's not too difficult to factor. That's going to be x minus 5 and 2x plus 1. I believe, minus 1, sorry. Okay, that works out. So that's our factored form for that polynomial. And of course we want that less than 0. So our zeros, we have x equals 4, x equals 5, and x equals 1/2. And so we go ahead and plot those on a number line. Okay. So 1/2, 4, and 5. Doesn't really matter if it's to scale, we're just creating our intervals. And I'm going to go ahead and use the leading coefficient as positive, so the far right of my graph is positive. And each of these zeros has a multiplicity of 1, which is odd. And for an odd multiplicity, the sign of our polynomial will change as we cross that 0. So from positive, as we move to the left, we'll change to a negative. And then as we cross 4, we'll change back to a positive. And cross 1/2, and we'll change back to a negative. And we specifically want when our polynomial is less than 0. So we're looking at the negatives. Okay? Because it's a strict inequality, we will not include the zeros. So we have negative infinity to 1/2, union 4 to 5. And that's the solution of our inequality.